Okay, so we already found our total time. We are moving on to max height. One thing to remember, velocity in the vertical, so in the y direction, its final would be 0 meters per second when it's at the top. The reason why is if you were to throw a ball, it would go all along this curve and it'd drop down here. At the top, velocity in the y direction is quite a bit, and then it's going to start slowing down, okay, because gravity is pulling it downward. So it's starting to get slower, 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 0 meters per second, then it'll start going downward. The velocity will start getting bigger, but in the negative direction. Okay, so it starts out really big, gets smaller, 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 gets to 0, bigger, bigger, bigger as it goes down. So here's our givens. We added one. VYF is 0 meters per second. Remember, we also have acceleration in the y direction. It's going to be negative 9.81 meters per second squared. Our unknown is y. So the equation we are going to use, we can't use the one that has time in it because that's total time. That's not the time for it to get to max height. Okay, that was the time for it to reach the ground. So we would have to use one that has VYF. And so we are going to use VYF squared equals VI squared sine theta squared plus 2AY. With this, we can rearrange the equation to solve for y. So we're going to subtract first, then divide by 2a, because we're going to do PEMDAS backwards. So VYF squared minus VI squared sine theta squared, all divided by 2a. From there, we just plug in VYF, so we're going to have 0 meters per second squared minus 12.5 meters per second squared sine 53.1 degrees squared divided by 2 times negative 9.81 meters per second squared. You should get 5.09 meters. Okay. So that's the height, but then we also need to add the 75 meters because we're starting 75 meters above the ground. So we'll have 75 meters plus 5.09 meters for a maximum height of 80 meters.